Hello, everyone. How are you? I hope all of you are doing very well. And so today we go to section 5.3. Section 5.3. Ito's formula. For our new theory of stochastic integration. The first Ito's formula. For our new theory of stochastic integration is given in the following theorem. Which was obtained by Hui and me in 2008. This is a very special case of Ito formula which says this in terms of the stochastic differential of a function theta of bt b1. This is given by theta. So theta is a function of two variables, x and y. And the differentiation in x dx b of bt b1 times bt plus 1/2 of theta sub xx bt b1 dt. Note that if b1 does not appear here, then the Ito formula within the Ito theory is given by the right-hand side. But for the appearance of b1, we have one correction term here. This is plus theta of x sub xy bt. Oh, this is too short. Okay, so here b1 and then dt. So you see the appearance of b1 requires these correction terms. And we will see later in this section that this can be derived from our theorem for the more general cases. Okay, so this is the introduction. This is the very first Ito formula for the new theorem. And in fact, if we look at this, of course, it's very nice formula, but there's something lacking there. Namely, we don't see the intrinsic meaning of the correction term, how it is related to b1. So we are going to do the more general case. So we will be concerned with the stochastic processes which can be expressed in terms of stochastic processes of the following form. First, x sub t equals to x sub a plus the integral from a to t, this t here. And then g s dbs plus the integral from a to t of hs ds. And this t is between a and b. So in the following, t will be understood to be in the interval from a to b. And here where g belongs to square error adapted from omega to L2 of AB. And H belongs to script L adapted stochastic processes from omega to L1 of AB. Namely, xt, that is, xt is an Ito process. And 2, y, now I use a sub t, is y sub b plus the integral from the integral from t to b psi s dbs plus the integral from t to b of eta s ds, where psi and eta are instantly independent. With respect to the filtration given by the Brownian motion. And so where this independent, and y sub t is also instantly independent. So this xt is Ito process is x sub t is an Ito process, and y sub t is in the counterpart. That is y t. This is in the counterpart. Counterpart in our new theory of stochastic integration. Okay, so we turn to the next page. This is page 43. And in terms of stochastic differential, dxt is gt dbt plus ht dt, and d of y sub t is minus psi t dbt minus eta t dt. And now let theta of xy is a C2 function. It's a C2 function of x and y. And then we ask the question. The stochastic differential of theta x sub t y sub t equals to what? So this is our question. We want to find out the stochastic differential. So we are going to do, we will use the same idea. The same ideas in the proof. In the proof of Ito's formula. Of course, this formula is within the Ito theory of stochastic integration that we have in the previous chapters. Okay, so we will use the same ideas in the proof of Ito formula to discover or to obtain, to discover the new Ito formula for our new theory of stochastic integration. Okay, note that. For this A to B. And we have T sub I minus 1, a partition T sub I over here. Theta x t y t equals to theta x sub a y sub a, then plus the summation I from 1 to n of theta of theta x sub I sub x sub t sub I y t sub I minus theta x t sub I minus 1 y sub t sub I minus 1. So see, this is just to add up in the right-hand side, to add up the increment of theta xy. Let me check this I, this I minus 1, I minus 1. Okay. I think this is enough for this video. And we'll continue in the next video.